Hello everyone, in this video I will share with you what an automation system is. Let's explore the most basic product combinations for achieving automation and how they work together. This presentation will be divided into three parts. First, we will give an overview of automation systems. Next, we will provide a detailed introduction to the basic hardware list that makes up an automation system. Finally, we will focus on explaining the connections and signal flow between these hardware components and deepen our understanding through examples. So how exactly does an automation system work? Its core logic is actually quite simple. It simulates human behavior patterns to form a closed loop of perception, decision-making, and execution. First, the system perceives its environment through sensors, just like human eyes and touch, providing the system with real-time and reliable input data. Next, the controller acts like the brain, analyzing and processing information, comparing it with preset programs and logic algorithms to quickly make precise judgments and control commands. Finally, actuators carry out actions, just like human hands and feet, directly acting on the production objects to complete specific tasks. This closed loop keeps cycling, enabling the machine to automatically complete tasks. So, what basic hardware do we need to build such a system? Here are 5 core components. First, the controller, which acts as the brain. This is the PLC. Second, the human-machine interface, HMI, which serves as the communication bridge. Then, the actuators as the limbs and the sensors as the senses. In addition, a power supply module, which acts as the heart, is needed to provide power to all the devices. First is the core hardware, the PLC, also known as the Programmable Logic Controller. It serves as the brain of the entire system, responsible for executing user-written programs, receiving input signals, performing complex logical operations, and outputting precise control commands. It coordinates the system's logic control, sequence control, and interlock protection, acting as the command center of the automated production line to ensure that equipment operates safely and efficiently, according to the preset process. The second core hardware is the Human-Machine Interface, or HMI, which is the touchscreen. It serves as our window for communicating with the machine, similar to a phone or computer screen. We use it to issue commands and also to monitor the operating status of the equipment. The HMI is the main interface for operators to communicate with the equipment. It is primarily used for starting and stopping the equipment, setting process parameters, real-time monitoring of operating status, and displaying fault alarms. It visualizes complex system data, making operation more intuitive and control more convenient, greatly lowering the threshold for operating the equipment. Next are 2 other core hardware components. On top are the actuators such as cylinders and motors. They are like the hands and feet of the system, responsible for carrying out specific physical actions. Common types include solenoid valves that control cylinders, contactors that drive motors, as well as the motors and cylinder bodies themselves. This is the key link that translates digital commands into mechanical movement. Below are the sensors, which serve as the eyes and nose of the system. They are responsible for detecting various states in the surrounding environment, such as whether there is material present or if an object has reached a designated position, and so on. After understanding each hardware component, let's take a look at how they are connected and work together. This diagram clearly shows the direction of signal flow and the control logic. First, the power supply provides electricity to the PLC, HMI, and other components. The HMI receives human command signals, and together with signals collected by sensors and other components, sends them to the PLC. The PLC then outputs precise control instructions to the actuators based on pre-programmed logic. After the actuators perform their actions, the results are either monitored by the HMI or fed back again by the sensors. The core closed-loop logic demonstrated here is that a person issues commands through the HMI. The PLC integrates input signals from sensors to perform calculations and output, which then drives the actuators. Once the action is completed, the sensors feed back the status signal to the PLC for the next logical judgment, thus achieving a precise and stable closed loop of automated control. Now that we've covered the theory, let's look at a practical example. The diagram shows a Siemens remote communication training box. The box on the left simulates the local station, while the box on the right simulates the remote station. The local and remote stations are connected via a communication cable in the middle. This training box uses buttons and indicator lights to simulate digital input and output signals, uses a potentiometer to simulate analog input signals from components such as sensors, and uses an ammeter to display the analog output signals from the PLC. This training box allows the buttons on the local box to control the indicator lights on the remote box, and the buttons on the remote box to control the indicator lights on the local box. The potentiometer on the local box controls the ammeter on the remote box, thereby achieving interconnection and communication between the local and remote boxes. In the local box, the HMI can communicate with both PLCs simultaneously, control the remote box, and monitor the status of both the local and remote boxes. That concludes my presentation. Thank you all for listening.